everyone, my name is Islin. I will be presenting introduction about HPLC. HPLC utilizes a liquid mobile phase to separate the component of a mixture. Analytes are first dissolved in a solvent and then forced through the column under high pressure. HPLC is very versatile because of its ability to easily separate wide variety of chemical mixture, which include non-volatile and thermally unstable compounds. For the principle, first begin by injecting the solute onto the top of the column. Second, separation occurs as the analytes and mobile phase are pumped through the column. And lastly, the response of the detector to each compound display and known as a chromatogram. For the objective, first, to determine the retention time of a standard solution, caffeine. Second, to identify the caffeine peak in the soft drink sample. And last, to determine the amount of a caffeine in the soft drink sample using the response factor method.
For the methodology, this is a full block of diagram of HPLC system. The HPLC system consists of solver reservoir, pump, injector, column, detector, data extraction system, and waste bottle, all working together to separate, detect, and analyze sample components efficiently.
Hi, I'm Shamimi. So I will explain about the HPLC components and their function. So we have 8 components here. The first one is HPLC solvent, also known as a mobile phase reservoir. It's used to store the solvent that carries the sample through the system and ensuring proper separation. Number 2, we have HPLC pump, which is responsible for delivering the mobile phase at high pressure flow and maintaining consistency in separation. Number 3, we have injector. It's where the sample is introduced into the mobile phase without disturbing the flow. Number 4, we have the sample, which is the substance that being analyzed, which move along the mobile phase into the column for the separation. Number 5, we have HPLC column, which is the core of the system, where the sample components are separate based on their interaction with the stationary phase. Number 6, we have detector, which is play a key role in identifying and quantifying the separated components by measuring absorbance or other signal. Number 7, we have a data acquisition system, which is the process the signal, detect, and generate a chromatogram for analysis. Last but not least, we have a waste reservoir, which is where the used solvent and sample residue are collected for the proper disposal. So that's all for the HPLC component and their function. Thank you.
Hi, my name is Nur Farhana and I will continue with the HPLC area percentage report analysis for different sample. All of the sample have the same wavelength of 254 nanometer and indicates a reference wavelength of 360 nanometer. Let's see for the first sample, which is standard caffeine. This report suggests that only one compound was detected in the sample, eluting at 2.482 minutes. Since its area accounts for 100% of the total, it represents the entire chromatographic signal for this sample with the total peak area at 6249.48 MAU. For the second result, it represents the caffeine in coke sample. The peak at 2.481 minutes represents the major compound in the sample given its high area percentage, which is 7001.123 MAU, while the other peaks represent minor compounds or impurities. And for the last result, it represents the caffeine in Levita sample. The largest peak at 2.01 minute is likely the primary compound of interest, contributing the highest peak at 3.48 times 10 to the power of 4. This report provided quantitative data for each compound detected during the HPLC analysis. And then, I will be presenting the caffeine concentration calculation for two beverages, which is Coke and Levita. First, we determine the response factor using a caffeine standard. The RF is calculated by dividing the peak area of the caffeine standard by its concentration. In this case, the peak area is 6249.48 and the concentration is 1000 ppm. So the RF will be 6.249 ppm. This RF value will be used to calculate the caffeine concentration in the samples. Next, we calculate the caffeine concentration in Coke. We divide the peak area of caffeine in Coke, which is 7001.123, by the RF value, which is 6.249 ppm, and it will give a caffeine concentration 1120.3 ppm in Coke. Similar to Coke calculation, the peak area for Levita is 3.48 times 10 to the power of 4, and we'll be dividing it by the RF 6.249 ppm, and we get a caffeine concentration which is 5578.3 ppm. They show that Levita contains significantly more caffeine compared to the Coke.
Hi, my name is Nur Elena Batrisha, and I will explain about our discussion. The experiment is expected to identify the retention time of the standard solutions, caffeine in a sample of soft drink, identify the peak for caffeine, and estimate the amount of caffeine through a response factor method. Hplc connects the pump inlet and push gas through the mobile phase reservoir. Glass bottle with special caps, Teflon tubing, filters, and purge gas. There are two different types of elution in mobile phases, including isocratic elution, which use a constant composition of solvents, and gradient elution, where the composition of the solvent is altered during analysis. Hplc also include a degasser, which removes the soft gases and dust, a pump which forces the mobile phase to flow through the packing, and injector which insert the sample into the mobile phase. There are two kinds of column, analytical and guard. The analytical column is a straight tube which is calibrated, while the guard column, when used, increases column lifetime by reducing the column deactivation. Hplc detectors may be divided into bulk properties detectors and solid property detectors. Bulk property detectors respond to some mobile phase bulk properties, while solid properties detectors respond to some property of solid themselves. Now, in this experiment, the retention time for the standard caffeine was 2.482 min with a peak area of caffeine being 6249.48779, while the retention time for Coke was 2.481 min with a peak area of caffeine being 7001.12305. Lastly, the retention time for Levita was 2.019 min with the peak area of caffeine at 3.4681. By using the formula retention time over response factor, the concentration of caffeine in the Coke and Levita can be known. The concentration of caffeine in the Coke is 1.1203 ppm, and the concentration of caffeine in the Levita is 5.5783 ppm. There might be some possible errors while handle the experiment. The error might be from the gases the sample.
Hi, I'm Hani. So to conclude this experiment, high-performance liquid chromatography (HPLC) was successfully used to determine the caffeine content in different soft drinks. The retention time and peak areas of caffeine in standard solutions and samples were analyzed using the response factor method. The results showed that the caffeine concentration in Coke was 1.1203 ppm, while in Levita it was 5.5783 ppm. The slight differences in retention times indicate the accuracy of HPLC in separating and identifying caffeine. However, potential errors such as improper degassing may have affected the precision of the results. Overall, this experiment demonstrated the effectiveness of HPLC in quantifying caffeine in beverages. So that's all from us. Thank you.